everyone. I hope everyone's back. Without further ado, yet again, I will ask Sebastian to do his paper on tree bark in the textiles of the Neolithic lakeshore settlements in southwestern Germany. Please.
Okay, thank you. Do you see my presentation?
Yes, it works nice, yes.
So today I will present you the TEFPO project. This project focused not on wood, but on the monocotyledons and mainly on the tree bust, which is the topic of my work and of this talk. I will talk about the project itself, the material and methods used, the building up of a reference collection with modern plant material. I will compare modern to archaeological material and will give an insight into my experiences with the ancient material. And at the end, I will conclude and give a short outlook. The TEFPO project started in 2018 and ended already in 2021. Its main focus was to research the prehistoric textiles and their significance in the context of pastoral Neolithic communities along the lake shores and wetlands of southwestern Germany in the state of Baden-Württemberg, which is indicated in red on the map. The interdisciplinary project has been undertaken by 5 co-partners, which were the Friedrich Alexander University of Erlangen-Nuremberg, the Julius Maximilian University of Würzburg, the Archaeological State Museum of Baden-Württemberg, the Kurt Engelhorn Center for Archaeometry, and the State Office for Cultural Heritage Preservation in the Stuttgart Regional Council, where I also work. The project was led by Dr. Johanna Bank-Burgess, who is responsible for the textile archaeology and is also from the latter named institution. Further analysis on lime bust was conducted by Professor Dr. Siegfried Fink from the University of Freiburg in Germany. The TEFPO project was funded by the German Federal Ministry of Education and Research. The aims were a full list of all archaeological textiles of the Neolithic and Bronze Age time periods, the production and tests on modern produced textile bark stripes and on bark and flax plait yarns, the anatomical description of modern monocotyledonous and tree bark material, and the botanical identification of the material used in archaeological textiles. And further information on the TEFPO project and a first publication can be downloaded or found at the website www.tefpo.de. Now, zooming at the southwest of Germany, or at the south of Baden-Württemberg, the state of Baden-Württemberg, here are the sites with textile preservation marked with green dots. Most waterlogged archaeological sites are found at the shores or the wetland area of the Lake Constance in south and on the lake in the south at the shores of Lake Constance and of Lake Federsee. I just realized there's the name cut on the east. About 2/3 of the textiles were found in Hornstadt-Hörnle, which is located where the yellow dot is. This drawing shows the reconstructed situation according to the pile plan. And before a big fire incident in the autumn of 3910 BCE happened which was proved by archaeological features and dendrochronological results. Therefore, from this place, many textiles have been survived due in the soil of the lake due to charring also. Here I present the different types of textiles that were found in all southwestern waterlogged settlements. The most analyzed textile types by me are, from upper right to bottom left, cords and ropes, excuse me, nets called baskets, bark containers, and twinings. Modern bark and barks from archaeological contexts were studied before, for example, by Müller at the turn of the 19th to 20th century, by Holtheide in 1952, by Körber-Grone in 1977, and later on. The bark features of the Java Journal by Angelossi et al. 2016, and the latest by Schweingruber et al. 2019. I have cut anatomical thin sections with the sledge microtome or lab microtome from the WSL in Switzerland until now of 17 tree species, resulting in a total amount of approximately 350 anatomical slides. The cut specimens were 10 to 60 micrometer thick. One set of these was stained with safranin to highlight lignin-rich tissues and with Astra blue to dye cellulose-rich tissues. The other set of thin sections were left unstained to be able to compare the uncolored tissues, modern tissues, to those observed in the archaeological material. The cuts were performed in the cross and the tangential section, but more work is planned to cover more tree species. A compilation of several determination characteristics, like the presence or absence of cell types, such as sclerenchyma, the arrangement of cell types, like in radial rows, or crystal types, were synthesized and will be published. The observation needs a good microscopic infrastructure with transmitted and reflected light microscopy, magnification between 50 and 500, and polarization filters. I will present you now some results. Here I present you two thin sections, a lime tree cross section on the left and an elm to the right. The thin sections are stained, thus lignified tissues are red and cellulose tissues are blue, like I mentioned before. Both are radially structured, mainly by sclerenchyma, parenchyma, and sieve tube elements. The bark is tangentially structured by the phloem rays that originate in the vascular cambium and are at the opposite direction to the medullary rays from the wood. The two cross sections appear different. Now concentrating on the lime. Lime on the left has two typical patterns that are in combination of diagnostic value for lime in Middle Europe. One is the dilatation of the phloem rays. And the second is the arrangement of the phloem fibers with the sieve tube elements. On this tangential sections of lime, again on the left and elm on the right, respectively, the phloem rays seem slightly different, but more pointed in lime, so on the left. Whereas the characteristics differ significantly. These are more septated on lime, but in lime, the phloem rays change dramatically through the phloem. The wedge-shaped, triangular dilating phloem rays appear heterogeneous along the gradient from the cambium to the outer bark, bark outside, sorry, bark outside. Tangential sections are indicated at two different positions with already quite a different appearance. On the left, again, the thin section near the cambium with 3 to 6 cells wide phloem rays. On the right, the rays already dilated by inserting new ray cells up to 14 cells in width and by widening of some ray cells. Furthermore, by looking at the cross-section, this fact becomes more pronounced towards the outer bark. Additionally, on the right, the phloem rays are higher. I will now give you an example of the comparison of archaeological plant material to the modern. On the left is the cross section, and on the right, the tangential section of a charred archaeological bark container from Hornstadt-Hörnli, which I've shown before. The relevant tissues are indicated here. By comparing those to the modern plant material, I can determine this as vine. Up to now, I analyzed 49 objects that divide into the here displayed manufacturing types. The main analyzed manufacturing types are coiled baskets, bar containers, and cotton ropes. From the botanical identification, lime is with 50% the most determined. 11% are lime to be conferred. Of the total number of 136 analyzed samples of these named 49 objects, 35% could not be identified. But from these unidentified samples, I could at least ascertain in almost 80% that it was tree bust, because of the presence of phloem rays that are indicated with arrows on this image. Now I want to share my impressions and experiences with the botanical analysis and the determination of archaeological tree bust material. The tree bark was either used unprocessed, therefore a lot of bust tissues are still present, as it can be seen here on the picture. But processing of the raw material, thus the tree bust, has a big influence on its features. For manufacturing, for example, a rope or string, the tree bust was often retted. Retting is the process of depositing tree bark into water for a specific duration, like 3 to 4 months, to be able to harvest more or less fine stripes of bust. During the retting process, parts of the bust tissues dissolve by microbial degradation and are therefore not preserved for the botanical determination. These stripes were in many cases further drilled to achieve different types of products. The phloem fibers are still together in a cluster, but either according to the duration of the retting and the usage, so how often it was used, these compound phloem fibers are often ripped apart, thus they are frayed out, like on the last image I'm showing here. Without the surrounding tissues, the determination is not possible up to date. Another influence on the determination of archaeological plant material is charring. Charring leads to clearly visible surfaces by breaking or cutting with a sharp razor blade of the dry material. This is important. Like it's done with wood. Breaking is practiced on the cross section, as it could be seen in the former slide, and cutting in the tangential section, which is presented here on the left side on this slide. If the sample is uncharred, it has to be either unconserved and wet or conserved to not dry out. These samples can either be observed underwater in reflected light microscopy, like here on the right, or by cutting thin sections with a razor blade in transmitted light microscopy. I mentioned before that the plant material has to be conserved to stop the drying process. Oops, sorry. The conservation agent often prevents the observation of features. The conservation agents fill the cells and often create glaring surfaces, like as shown on this picture. Dissolving these conservation agents is time-consuming and is often not satisfactory. This brings me to the conclusions and outlook of my talk. Thus, the best determination results are achieved when the material is charred or freshly excavated. So the charred and freshly excavated samples are easier to handle and to determine, in contrary to the conserved samples. So if an archaeological textile should be conserved, the identification should be conducted before the conservation, like it should be done with wood. I have produced thin sections of 17 species, but due to the lack of time, a detailed description and a first identification key was elaborated only for the 8 main tree species for textile production in southwestern German Neolithic. These results will be published in English soon. But the determinations on archaeological material and the development of the identification key for Middle European barks is still in progress. This brings me to the end of my talk, and I want to thank you very much for your attention.
Thank you very much, Sebastian. This is really, I'm always surprised at whatever, identification possibilities and new materials people come up with, all the time. So really, thank you very much.